my name is Elya Today, I will be presenting our proposed project, which is contactless monitoring of heart rate and respiration using RF sensing and deep learning. In recent years, the needs for non-invasive and continuous monitoring of vital signs has grown rapidly, especially in healthcare settings like ICU, elderly care, and even in applications such as driver fatigue detection. However, traditional contact-based sensor can be uncomfortable, cause skin irritation, and often give inaccurate results when user move. To address this challenge, researchers have started using radio frequency, which is RF, sensing technologies such as Wi-Fi channel state information with CSI, continuous wave radar, CW radar, and millimeter wave MM wave signal. So, despite the promising result, current RF-based monitoring system can have limitation. They often suffer from signal interference, slow or complex real-time processing, and accuracy issue in uncontrolled environment. To be used in real-life healthcare or safety critical situation, this system need to be smarter, faster, and more reliable. So our project has three main objectives, which is the first one is to develop a contactless system using RF signal like Wi-Fi CSI, CW radar, or MM wave for real-time detection of heart rate and respiration. So the next objective is to apply deep learning model such as CNN or RNN to classify and estimate this vital sign from RF data. And then the last one is to evaluate the system accuracy and reliability compared to traditional method and existing research. So now, what's within the scopes? The project will focus on simulation and algorithm development only. We will design signal pre-processing and feature extraction method to minimize noise and motion artifact. Apply deep learning to psychological signal classification and test performance using existing dataset and literature.
Hi, so here's a quick overview of our project timeline. So first, we'll design the pre-processing pipeline for RF signals, which will take about 1 month. Next, we'll remove noise from the data, followed by motion detection using Doppler shift, and each of these steps will take about 1 month. After that, we integrate both signals into one system and build apnea detection logic followed by real-time alerts, and all these steps are done within 1 month. Meanwhile, we'll also design the system architecture for hardware and software integration, and this will take time for about 1 month. On the deep learning side, we'll prepare and label our dataset, and that take time about 3 months. Then we'll develop, train, and validate the deep learning model in about 3 months total. So finally, we'll evaluate our system performance and deploy the full solution for live testing, and this will take about 1 month each. And that's the full roadmap in just under a year. Thank you. Each task has a design role, such as RF engineer, data scientist, software developer, and of course, the project manager. Here's our system framework. RF signals are acquired from the environment, then the data is cleaned and pre-processed. Feature extraction is done for breathing and heart rate. The deep learning model interprets these patterns, and finally, the system will detect any abnormal patterns and generates alert to the system. To manage this project, we created an AON diagram with dependencies between all tasks. The critical path we identified is A, B, C, D, E, G, H, I, J, N, and O. This path will take around 11 months or 44 weeks, and any delay in these activities will delay the whole project.
Now I'll explain about our budget in this project. Our estimate total budget for this 12-month project is 205,300. This budget includes several important areas. First, we allocated funds for hardware components such as RF sensor, ambient system, and computing devices for signal processing and AI model training. Second, we included costs for software tools, cloud-based deep learning training, and testing resources. The largest part of our project goes to human resources, covering the salaries of the project manager, RF engineer, and data scientist over the full project timeline. Lastly, we added a 10% contingency amount to prepare for any unexpected expenses, such as hardware replacement or additional data collection. As you can see from the slide, these are our key reference that we use to support our project design. All of them are published in recent years and are indexed in high-quality scientific database like SCIE and Scopus. This shows strong evidence that contactless RF monitoring combined with AI can achieve accurate and reliable results. We refer to studies involve CW radar, Wi-Fi channel state information, and wave system. We also study the latest deep learning methods for physiological signal analysis, including convolutional and recurrent neural network. These references give us confidence in feasibility and relevance of our proposed system. So in conclusion, our project aims to develop an intelligent contactless vital sign monitor system using RF sensing and deep learning. The system is designed to detect both heart rate and respiration without needing physical contact with the patient. This improves user comfort and solve issues that faced by traditional contact-based sensor, such as skin irritations and placement error. The system framework is clearly structured, covering signal acquisitions, pre-processing, AI-based detection, and real-time alert. We have outlined a we have outlined a 12-month timeline with well-defined rules and technical tasks. With proper validation and testing, this system can be used in hospital, elderly care, and even in smart home to improve health monitoring. Thank you. That's all for this video. Thank you for watching.